Hi everyone, this is Mr. Zirkle, and this video is an introduction to human population. You've probably been somewhere, say a concert or an overcrowded city street, and thought, there's way too many people here. Maybe not a place as crowded as the beach shown in this picture, but still, I think you know what I'm talking about. One of the most pressing issues facing the environment and its sustainability is the growth of the human population. For most of history, the human population grew pretty slowly. However, beginning in the late 1800s, population growth really began accelerating. If you take a look at this graph, you can see that it took about 12,000 years for the population to reach 2 billion people in 1928. It took about 50 more years to add another 2 billion people to the human population, and that was in 1975. And it only took 25 years after that to add yet another 2 billion people, this time in 1999. You can see the rapid growth that has been occurring, and this is called exponential growth. And it has the characteristic J shape that we expect to see with this type of growth. You may wonder at the reason for this exponential growth. One thing that may surprise you is that the rapid growth is actually due to a decreased death rate. People just aren't dying as fast as they used to. This is due to a number of reasons. For instance, an increase in food production and distribution. Many people now have access to food at supermarkets, and food is being produced on a grand scale and distributed regionally and globally. There have also been improvements in medicine and public health. People have access to doctors who can prescribe drugs to treat illnesses. We have better sanitation available to us. And additionally, our water supplies are safer than they once were. All of these factors have combined to bring the death rate down, which has in turn caused our population to increase. The basics of global population change are fairly simple. When there are more births than deaths, human population increases. When there are more deaths than births, population decreases. Instead of using the total number of births and deaths per year, we use something called crude birth rate and crude death rate. These are the number of births or deaths per 1,000 people in a population per year. To give you an understanding of what a typical number for crude birth rate or crude death rate is, for the United States, the crude birth rate is 12, while the crude death rate is 9. To find the growth rate of a human population, sometimes called the rate of natural increase, we use the following formula. We take the crude birth rate and subtract the crude death rate and divide by 10. This will give you the answer in percent. So for example, looking at the United States and plugging in the crude birth rate and the crude death rate from before, we get a growth rate of 0.3%. Another number that we can look at when it comes to population growth is the doubling time of a population. This is the number of years it will take for a given population to double in number. The formula for doubling time is fairly simple. We take 70 and divide by the growth rate. We always use 70. Don't worry about where the number 70 comes from. Just be sure you understand that it's always used. It even has a special name. The formula for doubling time is often called the rule of 70. Now, plugging the United States growth rate into the formula, we can see that the doubling time of the population is about 233 years. Okay, so we've discussed population growth in terms of births and deaths, but we left out an important factor. When we want to calculate the population change in a given area, we not only have to look at births and deaths, but also migration into and out of the area. The formula is fairly straightforward and should make sense to you. The first set of parentheses contain the two factors that increase population, births and immigration. We subtract from that what is inside the second set of parentheses. which contains the two factors that decrease a population, deaths and emigration, or migration out of the area that we are studying. So you may have noticed that birth rates and death rates are extremely important in determining what is happening to the human population. But what affects birth rates and death rates? Let's take a look at each one separately. Birth rates are affected by many different things, including social and cultural factors. For instance, one factor is how important children are as part of the labor force. In many third world countries, children are a necessary part of sustaining a family's source of food and income. In some nations, children are expected to help farm, find food, or work to support the family income. In these countries, birth rates are high because children are a necessary part of ensuring that the family survives. Another factor is the educational and employment opportunities that are available to women. In more developed countries, where educational and employment opportunities abound, women tend to put off having children until later in life and thus have fewer children. The cost of raising and educating children is another factor. In countries where the cost of raising children is high, such as the United States, women tend to have fewer children. There are other factors that affect birth rates as well. Infant survival rate, urbanization, the availability of family planning services, the average age of marriage, and religious beliefs, just to name a few. Now, let's just quickly run through the factors that affect death rates, since we discussed them briefly earlier in the video. Death rates are affected by things such as access to good nutrition and clean water, access to medicine, and adequate sanitation. Population growth in general can be affected by many different factors, and we can group them into two sets. We have density-dependent factors and density-independent factors. When we talk about density here, we're talking about population density, how closely packed together people are where they live. Density-dependent factors, those that are affected by how closely people live or proximity, include such things as disease. That should make sense. The closer people live to other people, the more likely they are to get a transmissible disease. Other factors include access to clean water and air, and the availability of food. Density-independent factors, things where proximity to other people don't matter, include things like storms, fires, heat waves, or drought. We know that human population is growing exponentially. It won't, however, be able to sustain that type of growth forever. As you might expect, our species population will be limited by Earth's carrying capacity. It's difficult to put a number on Earth's carrying capacity. If you talk to scientists, you'll find numbers ranging anywhere from 3 billion, which we've already passed, to 40 billion. The problem is carrying capacity varies depending on how people live and consume resources. We don't all live the same way, and because of that, it's difficult to estimate. There are a number of limiting factors for human population. As the population continues to grow, it will be more difficult to feed people. In the late 1700s, Thomas Malthus predicted that population growth, which is exponential, will at some point outpace food production. When the two meet, there will be too many people and not enough food. This is called a Malthusian catastrophe. Famine will occur, and the search for resources and food will cause wars. Also, as population increases, population density will increase, putting people at greater risk for diseases. Access to clean water and air will be an issue, and finally, the availability of land will come to be an issue as well. All right, well, that's the end of this video. If you have any questions or concerns, please email us, and we'll see you soon.